Okay, everyone, you should be attempting to work these problems prior to watching the video. So, determine if the following is a probability distribution, and if not, explain why. A probability distribution tells you the probabilities associated with all possible outcomes. Now, since it's a probability distribution, any particular outcome has a probability between 0 and 1. So if we look at this particular problem here, each probability is between 0 and 1. The second thing, they have to add up to 1. So do they add up to 1? 40, 80, 1. Yes. So this one is a probability distribution. Looking at the second one, each individual probability is between 0 and 1. When you add them up, you get 41, 81, 1.1, if I did that correctly, but they do not add up to 1. That does not add up to 1, so the answer to this one is no. The answer to this one is yes. Now for the second problem, I'm going to actually show you and explain the answer to you as opposed to actually working it out with you. And the reason why is because there's a lot going on here. So we have a probability distribution given up here. So you're reading the context of the problem. We're being asked to find the mean and the standard deviation. When you're giving a probability distribution, to calculate the mean, you must multiply each outcome to its associated probability. So each outcome is being multiplied to its respective probability. So you do the math, right? Each one. Then we added each one of these individual items up, and it equals 3.75. So to get the mean, you simply multiply outcomes to the associated probabilities, add them up, there's your mean. In order to get the standard deviation, you have to go through the variance, right? In order to calculate the variance, the first thing you need to know is what the exact mean is, which we just did. The second step, you take the difference between the data value and the mean, and then you square it. So you take the difference between the data value, so I'm going to clear out this right here. Just clear everything out here so we can see what's going on here. But I'm taking each data value, subtracting the mean, and then I'm squaring it. That's what each individual data value that I just checked off was obtained from. Again, if I take 0 minus 3.75 and I square it, I get 14. Once you do that, you take this particular number and you multiply it by the associated probability. So this number times this number yields this number. This number times this number yields this number, and etc. So you show yourself exactly what happened here. Okay? Once you calculate the variance, when you add these values up, once you calculate the variance, you take the square root to obtain the standard deviation. And there's your standard deviation. Again, there's your mean. Okay, read this particular problem. High school dropouts, approximately 10% of American high school students drop out of school before graduation. We choose 20 students entering high school at random. Find the probability that 2 drop out. So, we are looking at the number or the probability of so many things having a particular property. Either they drop out or they don't drop out. We did a sample. We took 20 students. We're asking how many. All of these things suggest a binomial distribution, which this is. So this is binomial, right? Because again, you're doing one of two things, dropping out or not dropping out. You are taking a sample and you're counting how many. That suggests binomial. So the probability that x is equal to 2 is equal to, I need to pick 2 from 20, then calculate the probability that 2 drop out. Well, it's 10% chance 1 drops out, so I square it because there's 2 of them. If there's a 10% chance of them dropping out, there's a 90% chance they don't drop out. Well, when you raise 0.9 to the 18th power, and the reason why is because if 2 dropped out, that means 18 did not drop out. Now, you can do the math. I am not going to do the math here. This is the understanding of the problem here, right? Well, if you do your math, you should come out with something very close to 0.2852. 0.2852. Question B, the probability that 1 graduates. All right, I'm asking about graduation now. So graduating is what's being talked about. I'm picking 1 that graduates, so from 20, I need to pick 1. The probability of graduating is 0.9 because your dropout's 0.1. There's 1 that's graduating, so the exponent's 1. Well, if 1 graduates, that means 19 are not graduating. The probability of not graduating is 0.1. Now you do the math, and if you do your math, this one is close enough that you can say the answer is 0. Again, this number here is going to be really, really small. And so, again, if you even keep that many places, you're going to find out that the final answer turns out to be really, really small. And if you round it, you will get 0. C, the probability that at least 3 drop out. So I'm looking for the probability that at least 3 drop out. Since this is a binomial and inequality, I am going to go with the normal approximation. Now, if I want to work with the normal approximation, one thing I'm going to need to know is the mean. And the mean for a binomial is n times p, which is, n is 20. We're talking about dropping out, so p is 0.1. So 20 times 0.1 is 2. The standard deviation is the square root of npq. Well, you show yourself that that's going to be equal to about 1.3416. N is 20, p is 0.1, q would be 0.9, the opposite, right? Now, since I am going with the normal approximation, I'm going to have to add or subtract a half a point, depending upon the particulars of the problem. Well, look at the problem. I am going in this direction. I'm starting at 3. I want to include 3. So if I'm going this way and I want to include 3, I'm going to start at 2.5. So it's the probability that x is greater than or equal to 2.5. Okay, now again, I personally like to switch to a less than or equal to sign. Okay, and do that, but that's what I normally do myself. All right, now how do I get to the table? I get to the table by subtracting the mean. Oh, let me get a finer pen here. Subtracting the mean, right? Yeah, that's better. Dividing by the standard deviation. When you do your math, you should get 0.37 about, right? This is the opposite scenario of the table, so I'll look up that number in the table, which I will assume you can do. When I look this number up in the table, I get 0.6443, and so when I do the math itself, my final answer is 0.36. Again, the idea here is not to do a bunch of calculations, but to show you the methodology, right? Binomial, using a normal approximation because this is an inequality. Step 1, make the half point adjustment. Step 2, get to the table. Step 3, what particular case is it for the table? Okay, exercise 4 is just working with the table itself. We are talking about a standard normal curve. Since we are talking about a standard normal curve, we are just working exactly with the table. Our first example is simply case 3. We are between the two numbers. So you look up 1.2 in the table and you get 0.8849. You look up 0 in the table, you get 0.5. You do your math, you get 3849. For the second one, we are to the right of z, meaning we are larger than z. You never know how to write it. You are expected to understand inequalities and that terminology. I am to the right of z. To the right of z means larger. This is opposite the table, right? So I'll look up 0.29 in the table, and I get 0.6141. I do my math, and the math comes out to be 0.3859. The next one, to the left of z. To the left of z is exactly what the table tells me. So I'll look up 2.01 in the table. 0.9778. That's what I get. The last one is another one to the right of z, meaning larger than z. Larger than z is opposite of what the table tells me. I look up negative 1.39 and I find in the table it is 0.0823. Do your math. 0.9177. So there are the answers for this. I am working with the assumption that you know how to work with the table, honestly, because at this point in time, if you can't, I just don't see you being successful. Okay? We've been working with the table for a while now. So anyway, that's what we have here. Okay? Okay, read this next problem, number 5. Look at it and try to identify the type of problem we are working with. All right, so read it, and I'm going to point out a few things. Okay, we are talking about the population of mortgage payments. We are asking the probability a monthly payment is something, right? A monthly payment is something, and this something, this monthly payment is normally distributed. In other words, we need to get directly to the table. This problem A is asking us the probability that X is larger than 1,000. Okay? Well, we need to get right to the table. We're talking about one member of the population. So Z is greater than 1,000. Let me fix that. In fact, put it down here. Subtract the mean. The mean is 982. Divided by the standard deviation, 180. We didn't mess with the standard deviation because, again, we're talking about a member of the population. When you do your math, this is the probability that Z is greater than 0.1. Well, this is opposite the table. Okay, so it is 1 minus what the table tells me, which is 0.5398. When you do the math, you get 0.4602. And there's your final answer. The probability that X is less than 1475. Same deal. First step is we need to get to the table. We're going to subtract the mean. 982. We're going to divide by the standard deviation, 180. Since we're talking about a member of a normal distribution, there's no adjustment being made here. When we do the math, it's the probability that Z is less than 2.74. This is exactly what the table tells me. So I look this number up in the table and I get 0.9969. And there's the final answer for that one. But again, it is so important that you are able to first identify exactly what the problem is. Okay, again, you read the problem, you try to identify the problem. Stop the video if you don't want to hear what I'm saying right now, but here we go. I am asking you for the probability about the mean lifetime of a sample. I am asking about the probability a sample mean is less than 23.8 months. That's what I'm asking for. Since I'm talking about the sample mean, the way I get to the table is first figuring out what the mean of the sample mean is. Well, by the central limit there, and that is exactly what the mean is for the population, 24.3. The standard deviation associated with the sample mean is equal to the standard deviation associated with the population divided by the square root of the sample size. When you do the math, you should get something that's equal to 0.45, I think it's 26. I wrote the numbers down here. 4526. Okay. Now I'm ready to get to the table. I get to the table by subtracting the mean, dividing by the standard deviation. I do the math. The math comes out to be minus 1.1. This is exactly what the table was telling me, so I'll look up minus 1.1 in the table, and I come out to be a 0.1357. There's your final answer. Okay, so again, problem about the probability associated with the mean lifetime of a sample. So the sample mean. Probability associated with the sample mean, we need to work with the mean and the standard deviation of the sample mean, which are given by these two here. Okay, here we go with another problem. You read over the problem, and I'm going to explain it to you in a minute. Well, less than a minute, because you can stop the video, right? Okay, so the probability associated with a percentage. There's how, this is how I identified the problem. Probability associated with a percentage from a sample. So I'm talking about the proportion type problems. The probability of sample proportion is at least 0.15. Now that I've identified the problem, I know I need to get to the table. The mean of the sample proportion is that of the population, which is 1 out of every 8, which is 1 over 8, which is equivalent to 0.125. The standard deviation for the sample proportion is the square root of p times 1 minus p over n. Substituting everything in, you can do that. 0.125 for p, so right here is going to be 0.875, right? N is equal to 16. So you get 0.0827. We have our mean, we have our standard deviation. We're now ready to get to the table by subtracting the mean dividing by the standard deviation, doing the math. When we do the math, we get 0.30. This is opposite of what the table was telling me. I find 0.617. Nine in the table. Subtract from 1, you get your answer. And your answer is 0.3821. Moving on to part B here. For part B, you look at this problem, it's talking about how many. Fewer than 4 graduate, right? We're talking about how many from a sample. We are talking about a binomial. Okay? Notice how proportions and binomial problems are very closely related. But in the first one, we talked about the probability associated with a percentage. Now we're asking how many. So we're talking binomial now. And if we're going to do a binomial inequality, our first step is to make an adjustment. This adjustment here is going to be subtracting a half. I'll do it up here in the corner because again we're below the number 4. We don't want to include 4, and we're heading in the left direction, right? Okay, so we're below the number, and so we had to subtract a half. Moving back to the problem, in order to get to the table, you show yourself that the mean, which is n times p, n is 16, p is 0.125, that is equal to 2. Sigma is the square root of npq, and I'm going to just give you sigma here because I'm lacking the space. But again, you should be able to figure that out. That's the square root of npq. Now I have the mean and the standard deviation. I'm ready to work with this right here. That's the probability of z being less than 3.5 minus the mean divided by the standard deviation. Doing the math, that's 1.13. That's exactly what the table is telling me. So I'm going to look up 1.13 in the table. We get 8708. So there you go. There you go. There's the last problem we have. Because it's the end.